Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter properties of matter. So any doubts, if you have in any steps, then please write that in the comments. And in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments so that we can give more priority on it and solve more and more questions on that chapter. So please install our Sapience education application where we shall upload some important questions based on every chapter of physics, which shall be obviously helpful for our exam. So here in the first question, it is told that the excess pressure inside a soap bubble is thrice the excess pressure inside a second soap bubble. Then the ratio between the volume of the first and the second bubble is. So as you know, the excess pressure in a soap bubble, suppose the outside pressure is P naught and the inside pressure is suppose P. Inside pressure is P, then P minus P naught, that is given as 4T by R, where T is the surface tension and R is the radius of the soap. So R is the radius of the soap bubble. Radius of the soap bubble. So now here it is told the excess pressure inside one soap bubble, that is thrice the excess pressure inside the second soap bubble. So the surface tension will remain same. So here the excess pressure, that is delta P1 inside the first so bubble, that is 4T by R1, and the excess pressure inside the second soap bubble, that is 4T by R2. So then here it is told delta P1 equal to 3 times delta P2. It means that 4T by R1, that is equal to 4T by R2 into 3. So 40 will cancel. So I can say that R2, that is equal to 3R1. So therefore, you can see that R1 by R2, that is equal to 1 by 3. So it means the ratio of the volumes that we have to find, V1 by V2, that is 4 by 3 pi R1 cube, that is by 4 by 3 pi R2 cube. Now 4 by 3 pi will cancel. So that is equal to R1 by R2 whole cube, which is 1 by 3 whole cube, that is 1 by 27. So 1 is to 27. So option B is the correct answer. And here it is told a spherical ball of radius. The spherical ball is there. Its radius is 10 power minus 4 meter. And its density rho, that is equal to 10 power 5 kg per meter cube. It falls freely under gravity through a distance h, before entering a tank of water, a tank containing water. If after entering in water, the velocity of the ball does not change. So it is told that after entering in water, the velocity the ball does not change. So it means the velocity remains constant. So here the velocity v, that will remain constant. So which will be the terminal velocity only. Then the value of h is approximately how much? The coefficient of viscosity, that is eta, coefficient of viscosity for water, that is 9.8 into 10 power minus 6 Newton second per meter square. Now, you know that so if the velocity is constant, it means the downward force, that is the weight mg, that should be equal and opposite to the upward force, which is the buoyant force and the viscous force. So now therefore the buoyant force plus the viscous force which is exerted on this spherical ball, that should be equal to its own weight mg. So the buoyant force or the upthrust, that is given as volume V, that is 4 by 3 pi r cube into sigma into g, where sigma is the density of water. So the density of water is 10 power 3 kg per meter cube. Power 3 kg per meter cube. Plus this is plus the viscous force, that is given as 6 pi eta r into V. 6 pi eta r V, that should be equal to mg. Mg means 4 by 3 pi r cube volume into rho into g. Now we know that we can cancel out pi. R also we can cancel. This will be r square. R square, and 2 also I can cancel. 2 to the 4. So here 6, 2 to the 4. And we can multiply both sides with 3 also. So then we will get 2r square sigma g plus 9 eta v, that is equal to 2r square rho g. So therefore v, I can say, which is the terminal velocity, that is equal to 2r square g into rho minus sigma, 2r square g into rho minus sigma by 9 eta, where eta is the coefficient of viscosity of the water. Coefficient of viscosity of water. So now we have to find, we can say that v square equal to u square. U is 0, v square plus 2gh. Since here there is air, so air we can ignore the friction of the air, which is the air resistance, we can ignore it. V square equal to 2gh. V will be equal to root over 2gh. Over 2gh. So then I can say therefore root over 2gh, that is equal to 2r square g into rho minus sigma by 9 eta. Now so the height h we have to find out. Now we can find out v. Therefore this v, that will be equal to 2r square R is 10 power minus 4, so 10 power minus 8 into G. G is 9.8 to rho. Rho is 10 power 5 minus sigma, that is 10 power 3, divided by 9 to eta, it is 9.8 into 10 power minus 6. This will be, these two will cancel, and we will get 10 power, so this will be equal to 2 by 9 into 10 power minus 2 into 10 power 3 into 100 minus 1, which is, so this will be 20 by 9 into 99, which is even so 220. Now therefore P is equal to root over 2gh. So therefore h will be equal to v square by 2g. So v square, that is 220 into 220 divided by 2g, which is 2 into g. G is 9.8. This will be 110. So g, if we take approximately as 10, then this will cancel. So 11 0, 11 2s are 22. That is a 22 for 2420 approx. Approx it is 2420, but slightly more than that. 2420. Is 48400 divided by 19.6. Approximately 2469.4 approximately. So the closest value we have to take, which is so the answer which is closest, with that is option closest answer is option A only. So option A is the correct answer. Here it is told a sphere of relative density sigma and diameter d has concentric cavity of diameter d. A sphere is there, which is having relative density sigma. It means that its density by density of water, that is sigma, and diameter is d, so the radius is d by 2, and the has a concentric cavity of diameter d, so its radius is also d by 2. The ratio of d by d is if it just floats on water in a tank is, so if it just floats, so if it is just able to float, it means that it is fully immersed inside the water. So it means the upward buoyancy Fp, that should be equal to its weight. So here there is the cavity and the solid part is on the outer side. So therefore the weight that will be equal to 4 by 3 pi d by 2 whole cube minus small d by 2 whole cube. Since this is the solid part, the volume of the solid part, volume into the density sigma into g, v sigma into g, and that should be equal to the buoyancy force. Here actually instead of sigma I can say the density of the sphere. The density of the sphere we can say rho s suppose into g. Fb is the, here the outer volume only have to take, since the volume of the water uh, displaced is same as the outer volume only, which is 4 by 3 pi into d by 2 whole cube into the density of water into g. So now the upthrust, which is the buoyancy force, that should be same as the weight of the sphere, since it is just able to float. So it means 4 by 3 pi into d cube by 8 into density of water into g, that is equal to 4 by 3 pi into 1 by 8 into, this is capital D cube minus small d cube into density of the sphere into g. So g will cancel, 4 by 3 pi, 4 by 3 pi, and 1 by 8, 1 by 8 will cancel. So from here we can see d cube equals to d cube minus d cube by d cube. No, sorry. D cube into density of the sphere by density of water. So which is the relative density of the sphere? The density of the sphere by density of water, that is given as sigma. This is given. So therefore I can say that uh, 1 that is equal to d cube minus d cube by d cube into sigma. So therefore I can say 1 minus d cube by d cube, that is equal to 1 by sigma. Now the ratio of d by d that we have to find out. Ratio of d by d that has been asked. Now from here we can see that d cube by d cube, that is equal to 1 minus 1 by 3. No, sorry, 1 by sigma. 1 minus 1 by sigma. So which means it is sigma minus 1 by sigma. So therefore d by d whole cube, that is equal to sigma by sigma minus 1. So therefore d by d, that is equal to sigma by sigma minus 1 whole power 1 by 3. Sigma by sigma minus 1 whole power 1 by 3. So option D is the correct answer. And it is told a cube of ice floats partly in water and partly in kerosene oil. The volume the ratio of the volume of the ice immersed in water to that of kerosene oil is. So let's say the height that is immersed in kerosene oil, that is x, and the height immersed in water, that is y. So therefore, the volume immersed in kerosene divided by volume immersed in water, the volume immersed in water, that will be equal to the area of the base, let's say that is A. So that will be area into x divided by the area into height immersed in kerosene oil, and the area into height immersed in water, which is y. So this is same as x by y. So if this we can find, then only we can find out the ratio of the volume of the ice that is immersed in water to that of kerosene. Okay. Immersed in water to that of kerosene. So x by y is not asked, y by x has been asked. Y by x we have to find, since y by x is equal to volume immersed in volume of the ice immersed in water by volume of the ice immersed in kerosene. So this value we have to find out. Now the specific gravity of kerosene oil is this. So it means the density of kerosene oil, the density of kerosene oil, that is equal to 0.8 into density of water, which is 0.8 into 1000, which is 800 kg per meter cube. And similarly, the density since y specific gravity is same as relative density. Now the density of water, that is 1000 kg per meter cube, and the density of this ice, that is equal to 900 kg per meter cube only, since here it has been told the specific gravity of ice is 0.9, so it is same as 0.9 times the density of water. Okay, so now here we can say that the weight of the ice, that is same as the net upthrust. So the net upthrust FB, that is equal to the weight of the ice. So now the net upthrust, that will be equal to the upthrust due to the volume inside water and plus the volume inside kerosene oil. So which is VAX into density of water into G plus AY into density, AX into density of kerosene into G and AY into density of water into G. So this will be the net upthrust, that will be equal to the weight, which is area into X plus Y, area into the uh, total height into the density of ice into G. Simply it means the net upthrust, that will be same as the weight of the ice. So A and G will get cancelled. So then we will have X into 800 plus y into 1000, that is equal to x plus y into 900. Now we have to find out y by x. So we can divide both sides by x. So then we will get, or with 100x we can divide both sides. Then here we will get 8 plus y by x into 10, that is equal to 1 plus y by x into 9. So therefore we will get 8 plus 10y by x plus 10y by x equal to 9 plus 9y by x. Y by x, that is equal to 1. So y by x, that is equal to 1. So it means y is to x should be equal to 1 is to 1. So answer is option D is the correct answer. Here it is told Young's modulus is determined by the equation given by y equal to 49,000 m by L dyne per centimeter square, where m is the mass and L is the extension of the wear used in the equipment. Now error in Young's modulus is estimated by taking data from ML plot graph paper. The smallest scale deviations are 5 gram and 0.02 centimeter along load axis and extension axis respectively. If the value of M and L are 500 gram and 2 centimeter respectively, then percentage error of Y is. So now you can say that so if you take log on both sides, so log Y, that is equal to log 49,000 into log M minus log L. Now if we uh, differentiate, this will be dy by y, that is equal to 0 plus dm by m minus dl by l. Now since errors should not be subtracted, so we have to add them. So I can say delta y by y, that is equal to delta m by m plus delta l by l. Now into 100 we can do, since we want the percentage error in y. So this into 100%, this into 100%. Since we need the percentage error, this value we have to find out, which is the percentage error in the Young's modulus y. Now therefore here the value of the Young's modulus, that is 49,000 into m they have told the mass taken, that is 500 gram, means 0. Okay, 500 gram, 500 only we can take 500 gram and L that they have taken is 0.02, no, that is 2 centimeter. So therefore this is 49,000 into 500 by 2. This will be coming in dyne per centimeter square. This is why all are taken in CGS units only. This is 250. Now, therefore, now delta y by y into 100%, that is equal to delta m. Now, the smallest scale divisions are 5 grams. So delta m, which is the absolute error in the mass, that is 5 gram. Delta L, which is the smallest scale division in the extension axis, which is extension axis, which is 0.02 centimeter. 0.02 centimeter. Delta M, that is 5 gram, 5 by 500 into 100% plus delta L, which is 0.02 by 2 into 100%. So this will be 500 is 500. So that 100 will cancel, and this will be 0.01, which is 1 by 100. And this will be also 1. So 1 plus 1%, which is 2%. So the percentage error in Young's modulus is 2%. So option A is the correct answer. Then we have to find the correct Bernoulli equation is. The correct Bernoulli equation is P plus rho GH plus half rho V square, that is equal to constant. P plus rho GH plus half rho V square is constant. So option D is the correct answer. Then pressure inside a soap bubble is greater than the pressure outside by an amount. So that will be obviously 4s by r, where s is the surface tension of the bubble and r is the radius of the bubble. So P, the pressure outside or the pressure inside minus the pressure outside, that is equal to 4s by r. So option B is the correct answer. Here it is told a small ball of mass m and density rho is dropped in a viscous liquid of density rho naught. Small ball having mass m and density is rho is dropped in a viscous liquid of density rho naught. After some time, the ball falls with constant velocity. The viscous force on the ball is. So the viscous force acting on the ball, that is how much? The viscous force, the net upward force is the viscous force plus the buoyancy force, and downward force is the weight. So when it falls with a constant velocity, then obviously the viscous force plus the buoyancy force, that will be equal to the weight. So therefore the viscous force, that is equal to the weight minus the buoyancy force when velocity will be constant, when it will move with a constant velocity inside the liquid. Then so the viscous force, that will be equal to weight, which is mg, minus fp, which is volume into the density of the liquid rho naught into G. Now volume, we can say volume equal to mass by density. So therefore the viscous force that is equal to mg minus m into rho naught by rho into G. So from here mg I can take as common, mg into 1 minus rho naught by rho. So mg into 1 minus rho naught by rho, this will be the viscous force acting on the ball. So option A is the correct answer. And here it is told a force that restores an elastic body of unit area to its original state. Or that restores an elastic body of unit area to its original state. And two equal and opposite forces uh, parallel to opposite faces. So that will be causing shear modulus. So B will be the fourth one. So it means we have to choose from B and C. So here it is force per unit area only, and these forces perpendicular everywhere to the unit everywhere to the surface per unit area, same everywhere. Forces perpendicular everywhere to the surface per unit area, same everywhere. So that will be the bulk modulus. So C will be obviously 1, and D will be two equal and opposite forces perpendicular to opposite faces. Okay, two equal and opposite forces perpendicular to opposite faces. Then that will cause Young's modulus. That is the second one. So D will be 2. And so obviously A will be the third one, which is stress. So force that restores an elastic body of unit area to its original state. So I can say it is force per unit area, that is stress. So A3, B4, C1, D2. So option B is the correct answer. And it is told when a capillary tube is dipped into a liquid, the liquid neither rises nor falls in the capillary. The contact angle may be 0 degrees. So the capillary rise H, that is given as 2t cos theta by rho gr. 2t cos theta by rho gr, where T is the surface tension and theta is the angle of contact, or I can say it is the contact angle. So if the H is 0, if the where H is the capillary rise in the capillary tube, so if H is 0, then it means that angle theta should be 90 degrees. Theta is equal to 90 degrees. Theta is 90 degrees. Theta is equal to 90 degrees. Then statement 2 is the contact angle between a solid and a liquid is a property of the material of the solid and liquid as well. The contact angle between a solid and liquid is the property of the material of the solid and liquid as well. So option statement 2 is true, and so the statement 1 is false. Since why here the contact angle has to be 90°, then only the capillary rise will be 0. So statement 1 is false, but statement 2 is true. So option B is the correct answer. It is told the contact angle between a solid and a liquid is a property of the material of the solid and the liquid as well. So option statement 1 is obviously true. And the rise of a liquid in a capillary tube does not depend on the inner radius of the tube. That is false. That's why rise of the capillary rise is given as 2t cos theta by rho g r. Rho g r. So it is inversely proportional to the radius of the tube also. It is inversely proportional to the radius of the tube. That is r. So hence statement 1 is true, statement 2 is false. So option D is the correct answer. Then here it is told with when speed of liquid is 0 everywhere, pressure difference at any 2 point depend on the equation P1 minus P2 equal to rho G H2 minus H1. Statement 2 in Venturi tube shown 2GH that is equal to V1 square minus V2 square. We have to solve it. So now pressure difference that is obviously rho GH into H2 minus H1. So here H2 minus H1 is H. So statement 1 is obviously true. It's true. And so if we apply Bernoulli's equation, P plus half rho V square plus rho GH that is equal to constant. Now P1 plus half rho V1 square plus rho GH1 that will be equal to P2 plus half rho V square half rho V2 square plus rho GH2. Now here the height of these 2 points are same only, so these two will cancel. But so P2 minus P1 here, or P1 minus P2, that is equal to half rho into V2 square minus V1 square. P1 minus P2 that is equal to now P1 minus P2 is that is rho GH here. H1 minus H2. H1 minus H2 that is H. This will be minus H since P1 minus P2 is H2 minus H1. So H2 minus H1 that is obviously minus H since H1 minus H2 that is H. So this is equal to half rho into V2 square minus V1 square. Now rho and rho will cancel. So I can say 2GH that is equal to V1 square minus V2 square. So obviously this is also true. Statement 1 is also true, statement 2 is also true. So both statement 1 and 2 are correct. So option B is the correct answer. Here it is told a big drop is formed by coalescing 1,000 small droplets of water. The surface energy will become. So here, a big drop is formed by coalescing 1,000 droplets of water. Now the surface energy will become how many times? Now we know that surface tension that is given as uh, change in surface energy by change in surface area. So it means the change in surface energy that is equal to the surface tension into the change in surface area. That means the surface energy is the change in surface energy is directly proportional to the change in surface area. So now here, the surface area will decrease obviously. Since why? Initially, suppose the radius of each of them is r, so then it will form a new droplet having radius capital R. So I can say 1,000 times the volume. If we apply conservation of mass here, if we apply conservation of mass here, then it means we have to conserve the volume also. So it means that 1,000 into the volume of each of them, which is 4 by 3 pi r cube, that is equal to the volume of the large drop. So the volume of the big drop, that is 4 by 3 pi capital R cube. So 4 by 3 pi will cancel. So r cube equal to 10 power 3 into r cube. So it means r equal to 10r. So it means the radius of the larger drop, that is 10 times the radius of each small droplet. So therefore, the surface area, so the initial surface area was 1,000 into 4 pi r square. The total initial surface area. The final surface area is 4 pi capital R square, which is 4 pi into 10 R whole square, which is 100. So it is 100 into 4 pi R square. So obviously the surface area has decreased by 10 times. So therefore delta A, that is A final minus A initial, that is equal to is 900 minus 900 into 4 pi R square, which means it is minus of 9 by 10 times the initial surface area. Therefore, the decrease in the surface area, that is minus delta A by A initial in A initial. So that is, which is the fractional decrease. So minus delta A will be 9 by 10 into AI, that is by AI to yeah. Or here actually it is told that the final area, that is 1 by 10 times of the initial area. So it means the surface energy, the final surface energy will be also 1 by 10 times the initial surface energy. So the surface energy will become 1/10. Option D is the correct answer. So here it is told with rise in temperature, the Young's modulus of elasticity. With rise in temperature, the Young's modulus of elasticity, what will happen? So we know that Young's modulus of elasticity, that is nothing but force by area by delta L by L, which is stress by strain. Now with rise in temperature, the strain will not change. The force per unit area, which is the stress that is, and actually Young's modulus, it is a property of the material. It's a property of the material. So it is independent of temperature. So whose value is independent of temperature. So hence it means that the Young's modulus hence with the rise in temperature, I can say the Young's modulus will remain unchanged. So option D is the correct answer. And here it is told a small spherical ball of radius r falling through a viscous medium of negligible density has terminal velocity v. Another ball of the same mass, it falls through a viscous medium of negligible density. It means sigma, that is 0. The density of the liquid, I can take it as approximately 0. And it has a terminal velocity v, and its density is suppose rho. Another ball of same mass, its mass is same, but of radius it is 2r. Radius is 2r. Falling through the same viscous medium will have terminal velocity how much? So its terminal velocity, let's say v1, that would be how much that is being asked. So now here we can say the terminal velocity v, as we know, that is 2r square g into rho minus sigma by 9 eta, where eta is the coefficient of viscosity of the uh, liquid. Eta is the coefficient of viscosity of the medium through which it falls. So now V will be equal to 2r square into g into rho, since sigma is approximately 0 only, by 9 eta. And here V1, that will be equal to 2 into 2r square, 2r whole square. So here actually we can do one thing. We can do it like this, that is the downward force, that is the weight that is mg, that should be equal to the viscous force when there is terminal velocity, the viscous force, that is 6 pi eta rv plus 4 by 3 pi r cube volume into density sigma into g. Since here sigma is approximately 0, so we can cancel this. So here velocity, terminal velocity will be mg by 6 pi eta r. mg by 6 pi eta. Similarly, here V1 that will be equal to mg by 6 pi eta into 2r. So which is obviously V by 2. Which is obviously V by 2. So option D is the correct answer. And here it is told a small steel ball is dropped into a long cylinder containing glycerin. Small steel ball is dropped into a long cylinder. Small steel ball. Small steel ball. The steel ball which is dropped into a long cylinder is dropped into a long cylinder containing glycerin. Okay. So here glycerin is there. Then which one of the following is the correct representation of the velocity time graph for the transit of the ball? So gradually what will happen, this is mg, this is the viscous force which is V into sigma into g. Sigma is the density of glycerin and rho is the density of the steel ball. Suppose so this m will be V into rho, V rho g. And upward there will be the viscous force 6 by eta r v. Now gradually the velocity will increase, then the viscous force will increase. So the upward force will increase. So it means the velocity will gradually become constant. So it means option B is the correct answer. Here slowly the velocity will gradually increase and at some point the velocity will become constant since and then that velocity will be called as the terminal velocity of the steel ball. And here it is told Young's modulus of a material of where of length L and cross sectional area A is Y. So if the length of the wire is doubled and cross sectional area is halved, then Young's modulus will be. So Young's modulus is independent of the length and cross sectional area. Since by Young's modulus, it depends only on the material of the wire. It depends only on the material of the wire. It is independent of the shape and geometry of the wire. So hence it will remain Y only. So option D is the correct answer. Then a small liquid drop of radius R. There is a small liquid drop of radius R that is divided into 27 identical liquid drops. 27 identical liquid drops, each having radius small r. So if the surface tension is T, then the work done in the process will be. So work done that will be equal to the surface tension into the change in the surface area. T delta A, that is equal to delta W. Work done is equal to surface area change into the surface tension. So the change in surface area, that is equal to the final surface area minus the initial surface area. So now the initial surface area, that is equal to obviously 4 pi r square, and the final surface area, that is 27 into 4 pi into small r square. Now we have to find a relation in between small r and capital R. Now we can apply the conservation of mass, since the density of the liquid drops will be same, so the volume also will remain conserved, means the initial volume will be same as the final volume. So initial volume is 4 by 3 pi capital R cube, that is equal to 27 times 4 by 3 pi small r cube. 4 by 3 4 pi will cancel, 4 by 3 pi will cancel. So r cube equal to 27 r cube, so that means r will be equal to 3r, since 3 cube is 27. So the uh, small r is r by 3. So therefore the final area, that is equal to 27 into 4 pi into r square by 9. So 3 nines are 27, which is equal to 3 into 4 pi r square. So now therefore the work done, that is delta W, that is tension, surface tension force into final area, that is 3 into 4 pi r square minus 4 pi r square, which is the initial area. So it is T into 2 into 4 pi r square, which is equal to 8 pi r square T. 8 pi r square T. So option B is the correct answer. And here it is told a wire of length L and radius R is clamped at one end. A wire of length L and radius R. A wire of length L and radius R that is clamped at one end. It is having length L, radius is R, is clamped at one end. If its other end is pulled by a force F, so it is not told that it is kept vertically, so it can be kept horizontally also. It is having length L, and in this part it is clamped, and on this side it is pulled by a force F. Its radius is R. Its length increases by L. Its length increases by small l. Its length will increase. If the radius of the wire and the applied force both are reduced to half of their original uh, values, if the radius of the wire and the applied force both are reduced to half of their original values, keeping original length constant, the increase in length will become. So here it is told that if now the new force F dash, that is F by 2, and the radius R dash, that is R by 2, then the increase in the length, that is L dash, that will be how much, that is being asked. So here we can say that the Young's modulus will remain constant. Why? Since Young's modulus, it depends only on the material of the wire. It depends on material of the wire only. So therefore we can say that F by A, that is equal to Y into delta L, that is L by L. So therefore L, that is equal to FL by AY. Now, so therefore L dash, that is the new value of extension, that is equal to, so A is the area of cross section, which is pi r square. Therefore L is FL by pi r square into Y. Now therefore L dash, which is the new extension, when the force is being halved and the radius of cross section is also halved. So that will be F by, which will be equal to F dash into L by pi R dash square into Y. So F dash is F by 2 into L by pi into R dash, which is R square by 4 into Y, which is equal to 4 by 2, that is 2 into F L by pi R square Y. So which is twice of L. So L dash is twice of L. So it means the increase of in the length will become 2 times. So option A is the correct answer. So then the thing is, if a first statement is, if a capillary tube is immersed first in cold water and then in hot water, the height of capillary rise will be smaller in hot water. So capillary tube is immersed in cold water and then in hot water, the height of capillary rise will be smaller in hot water. Since why the surface tension will increase with temperature increase. So therefore, the height of the capillary rise is 2t cos theta by rho gr. Now, the radius will also increase, surface tension will also increase. So height of capillary rise will be smaller in hot water. If a capillary tube is immersed first in cold water and then in hot water, the capillary rise will be smaller in cold water. Now, the thing is, so here surface tension will decrease with temperature. Thing is that when temperature increases, the surface tension S that decreases. So we can write H equal to 2s cos theta by rho gr. So in hot water, the capillary rise will be lesser. The capillary rise is lesser. So in hot water capillary rise will be lesser. So statement 1 is true and capillary rise will be smaller in cold water, that is false. So first one is true, statement 2 is false. Statement 1 is true but statement 2 is false. So option C is the correct answer. Then it is told the property of a body by virtue of which it tends to regain its original shape when the external force is removed is called elasticity. It is true, and the restoring force depends upon the bonded interatomic and intermolecular force of the solid. That is also true. So here, the thing is, um, The restoring force, it will depend on the bonded interatomic force. So if the interatomic force is strong or the intermolecular force is strong, then it means the restoring force will be also higher. The restoring force will be higher, and then the elasticity also will be higher. So it means the statement R is true and A is also true, and R is the correct explanation of A. So option C is the correct answer. Here is velocity of gases is greater than liquids, and the surface tension of liquid decreases due to the presence of insoluble tension of decreases due to the this statement is false, then the second gases has less viscosity tension soluble impurities, like in the case of soap or detergents, the surface tension decreases due to soluble it is told exerts the Young's that will extend in the how much L by L train Young's by strain delta L, that will be by A is the in the that is two the area of cross section, that is 2 centimeter square. Now 1 centimeter square means it is 10 power minus 4 square. Young's plus it is 10 power to 11. So 2 and 2 will get cancelled. So this is 200 by 10 power 11 minus 4, that is 7. by 10 power. You can see which means 3 micro. So 20 micrometer is the extension. T is the answer. Water it's of yes 0 form. They are following the terminal per second. Condensation if 8 such fullest 8 such fullest draw the new terminal velocity here terminal velocity will be how radius will be 8 into 53 pi r volume will be in the density of the if we apply conservative law of conservative volume will be conserved also. If we cancel that means radius is twice of the radius of each. R square. Here we can see that the terminal velocity is directly proportional to square. Here it means that is equal to r square. That the ratio of the r it means the ratio of the terminal velocity also will be 4 by the remaining parts are remaining. Therefore, the new terminal velocity will be 4 times of the previous terminal, which is 10 centimeter per second. So it will be 3 centimeter. 3 centimeter. A liquid column of height. Liquid column is 0.0 centimeter. That balances the pressure of a soap bubble of 16 0 point balances bubble has here the excess pressure by R. Rate of the therefore here the excess pressure P that will be equal to GH. The density of meter cube, surface tension that is it diameter of the soap find out. Which means 4 power minus centimeter. That since by 1 centimeter. Is 0 the bubble is 3 centimeter. The has been asked. 7 plus of edge Hence, it will improve acts from six. Here we can see the MG that this is tension 4. So this is 90 again. Cos theta. So their magnitude is small. Yeah, so theta will be 1. Here sin theta we can write approximately. Therefore, 2into theta. Tension for per unit area is the L by delta L by L. If you extension of delta L by L is L into L into L into 1 plus Nx cancel. So delta L by L sin theta also I can say that is approximately L into therefore x square by 2 L square theta square by theta square by we have to find D tension for A modulus 7 3 by A L by L is 1 by A will be big drop is of surface energy of 1000 now, as we know, the energy is directly surface. That means it is the ratio of the surface area of the droplets. A1 is the surface area, total surface area of the so the volume will be mass is being served and the density is so the volume of this the total volume of air cube the capital R by 354 by 3 cancel. So the surface area of the rock by surface area of cancel. Hydraulic pumps with dam figure. Here the diameter is the radius that governs, and here the radius small r that is 0.7 t. And of 10 Newton is applied on the surface of 10 Newton is required to be applied on water in the thicker arm to maintain equilibrium of how much force. So the thing is, if we apply the Pascal's law, then the excess pressure that is being formed at this point, that will pressure that is being formed at this means P1 will be equal to P2. So which means that F by A1 that is by A2. That is 10 Newton, and area for the first arm that is A1 that is 4 pi into R1 square 0.7 whole square pi into the sorry that is pi r square actually pi r square pi into 0.9 pi into that is equal to F2, which we have to find out F2 by A2. A2 is pi into R is 7 centimeter. 7 pi will get cancelled. That 7 square pi into 10. 7 square by 7 by 10 whole square into 10. This will be equal to 10 square, which is 100 into 10, that is 1000. 1000. Then Newton is the force that should be applied. The current. That is the answer. Then here it is told the density and breaking stress of a square. So the density is 6 into 10 kg per. Breaking stress L by L. It is given as 1.2 10 power. Breaking stress, it means F by A. Sigma only. 10 power 8. Air is suspended from a rigid support on a planet where the acceleration due to gravity is 1/3 of the value on the Earth. The with so we have to find the breaking stress is applied. Now we can say that sigma, that is equal to Young's modulus the wire suspended from a rigid vertically, then its weight will act, that is mg mg dash, I can say, and where g dash on that planet is 1 by 3 times g. Then density is this, breaking stress is this, sigma, that is y into epsilon, which is epsilon is the strain, force mg stress, that will be force dash by area of cross section, that is into delta L by L. The maximum length of the wire that we have found. So now delta L. So the maximum length of the wire, that will be equal to L plus delta L, which is the L is the actual length of the wire and delta L is the extension of the wire. So this L2 M, mass of wire, mass where I can write M into density of the wire. M is a area of cross section, the length is AL by into delta L by L. this will get L square rho dash by G dash is obviously G by 3. Therefore, the maximum length of the wire with breaking, that is L plus delta L, sigma that is given as y into delta L by L. Therefore, delta L will be sigma L by y. At delta L, we can obviously sigma is obviously equal to LG in L rho into G by 3. That L also delta L will be by. So it means that L will be equal to 3 sigma by rho G. The length of the, so therefore length will be E into sigma, that is 1 10 power 8 by this 6 into 10 power is 10 equal the 6 to 6 12 0.6 into 10 power 8 minus 5, that is 3 600 length 100 third. We have delta L also. Delta L is sigma L by pi, where the Young's modulus is not. So it means delta L we don't have to find, and also delta L is negligible as compared to L. So we can tell that the maximum length will be 6 meters only. 600 is here it is told mercury is filled in a tube of radius 2 centimeter up to a height of 30 centimeter. The tube having radius 2 centimeter up to the height of 30 centimeter. Height of 30 centimeter. The force exerted by mercury on the bottom of the tube. Force exerted by mercury on the bottom of the tube. Force exerted by mercury bottom of the plate. Force will be equal to obviously mg. Mass is V, volume into density into G. The volume is equal to A into H into rho into G. So A is pi r square, pi r square. So pi r square into H into rho into G. This will be the force. The force will be pi into r square. Pi is 22 by 7. We have to take it is told pi into r square. R is 2 centimeters. So 2 into 10 power minus 2 meter whole square into H 30 centimeters. So 30 into 10 power minus 2 meter to rho. Density is 1.36 into 10 power 4 into G. G is 10. Okay, and the atmospheric pressure is also 10 power 5. So here the actually the force exerted that will be equal to the pressure into the area, and pressure here that will be equal to P naught plus rho GH. So force that will be equal to pressure into area, so which is P naught into A plus rho GH into A. Will be equal to P naught plus rho GH into pi r square. So that we have to find out. So this is actually wrong. Here we have to do the force that will be equal to P naught plus rho GH into A. This pi r square. So P naught is 10 power 5 plus rho GH into area, that is pi r square. We can say this is pi r square into this is H rho G. This is H rho G plus 10 power 5. This much Newton we will get. H rho G plus 10 power 5. This will be 22 by 7 into 4 into 10 power minus 4. Here also 10 power 4 I can take as common outside. So then this will be 0 0.3 10 1.36 plus 10 Newton. So these two will get cancelled, which will be 1, which is 88 by 7 into with 3 into 1.36, 3 into 1.36 plus 10, which is how much? So 3 6 18, 3 6 18, 6 is 9 10, 0.08 plus 10, which is 14.08 into 88 by 7. This much. Then is approximately 7 twos of 14, 2.07 7 to 88. Then approximately is approximately 2 8 is 16, 76. Then approx. The approx value of the force exerted by Mercury at the bottom of the tube is 176 ton approx. We can tell 101, so approximately with 177 also we can take. 177 is the answer. And here it is told a soap bubble is blown to a diameter of 7 centimeter. The diameter, so R will be 7 by 2 centimeter. 36960 arc of work is done in blowing it further. This much arc of work is done. Therefore, the work done, you know that is 36960 arc. If surface tension of the soap is 40 dyne per centimeter, then the new radius is centimeter. Okay. So therefore, the work done, that is equal to T times delta A, where delta A is the change in the surface area. The new radius. So purple is blown diameter of this. So the soap has two surface areas. So the final surface area is, it will be 8 by r square, r2 square suppose. The initial area, that is 8 by r1 square suppose. Since why there are two spherical surfaces, so that will be t into 8 pi into r2 square minus r1 square, and r1 is 7 by 2. Therefore 36960, that is equal to P into P into 8 pi into r2 square minus 7 by 2 whole square. So it means that 22 by 7. So t into 8 into 22 by 7 into r2 square minus 49 by 4, that is equal to 36960. Now with 11 I can cancel. 11 2s are 11 3s are 11 3s are 33, 11 6 are 66, 0, and then 2 1s are 2, 2 6 are 12, 2 8 is 16, 0, 8 with 8 I can cancel. 8 to the 16, 8 1s are 8, 0. So then it means surface tension is 40. So 40 by 7 into r2 square minus 49 by 4, that is equal to 210. 0 0 will cancel. So then r2 square minus 49 by 4, that is equal to 21 into 7 by 4. So r2 square, that will be equal to 7 on the 7, 7 to the 14 by 4 plus 14 by 4, which is equal to r2 square, that will be equal to 50 if we add that is 196 by 4. So 196, so 4 4 is 16, 4 9 is 36. So r2 will be equal to 7. So the new radius is 7 centimeter. So 7 centimeter is the new radius.